All right, so we can start. Welcome, everyone. Today, we're going to talk about building cloud-native platforms with Kubernetes. So this is a very practical presentation. So hopefully, if you have anything to do with platforms, you raise your hand if you're building platforms or done anything to help developers to build platforms. Awesome, 2 people, great. So hopefully, you're going to get some cool ideas from it. All right. A little bit about me. So I mostly work with Kubernetes, Docker, Go, and all that stuff. I work with a company called Loft Labs, and we like Kubernetes so much that we put Kubernetes in Kubernetes. So if we cluster, that's what we do. In my free time, I usually do stuff with open source, and I also attend conferences, which is fun. And I tweak my Linux. I don't recommend if you want to have some free time, please don't do it. You can find me online on cloudrumble.net. I'll snap this QR code. Be happy to connect on LinkedIn or otherwise. All right, let's start. So there are all kinds of platforms we can talk about. So if you're a platform engineer or doubled into this a little bit, I like to divide it into these 3 broad categories. So we have business platforms. If you think of apps like Uber or DoorDash, they are essentially platforms in and of themselves. So they provide ways for customers and business to conduct transactions. So that's one kind of platform. Then we have domain-specific platforms. If you have ever developed a service that does something that's like a cross-cutting concern, a good example could be, for example, a geolocation service that many applications use. So this is also a type of platform. And finally, domain-agnostic platforms, those are the platforms that provide functionality that is cross-cutting, typically low-level. And this is the type of platforms we're going to talk about today. So infrastructure-focused developer platforms. We want to provide developers a way to create infrastructure in a frictionless way. So that's the idea. So what are the benefits? The resource management is much simpler. We are also cutting down the potential blast radius. If something goes wrong, we don't need to give people access to cloud providers or wherever we deploy infrastructure. So it's standardized and simplified. We ideally increase development efficiency. However, at the beginning, it might slightly dip when people learn all this stuff, but the idea is that you want to definitely help developers to increase it. And then platforms are meant to be scalable, reliable. So they take the whole concerns that developers typically don't deal with and try to codify it inside of a platform. We will have things like SLAs, SLOs, and all other metrics that we SREs know and love. What are the building blocks of a cloud-native platform? So this is not an exhaustive list, but those are the building blocks that typically you can find in any good platform, right, or well-developed. So some form of self-service portal, you have Backstage, you have Port. I'm going to use Port for the demo. But there's a way of doing it. You don't have to have it. You can just use YAML, but it's confusing for developers. So you need something that somebody can go to a UI and click a button and spin up infrastructure. Programmatic APIs, we are going to, hopefully I will convince you that standardizing on APIs is a way to go, and specifically on Kubernetes APIs. So this is a way how you can expose an API surface for developers and actually treat them as APIs. Automated workflows, we'll talk about GitOps, monitoring observability, so obviously Prometheus and all that stuff, or other solutions, right? Security and governance controls. Platforms very often codify those things so that at one hand, developers have an easy life creating infrastructure or other artifacts, and at the other hand, compliance and security teams are happy because behind the scenes, there's a lot happening to make sure that everything is secure. And finally, platform is ever evolving. So this is a product. You have to treat it as product, think about it as a product. So best practices that I've seen in the field and also from my experience developing platforms for many years, again, API driven. If you start thinking of a platform, not necessarily as a UI or as something that is like a foundation underlying something, but rather as what kind of API can I expose to my developers? This is the good starting point, and focusing on API, giving API guarantees, versioning, everything around it. That makes it so that the platform can be developed independently, and the API is actually a contract between you and developers. Using cloud native principles, obviously we want to use technologies like Kubernetes or other technologies that make it cloud native and make it portable to a degree, obviously. And a GitOps workflow, which is currently probably now, I would say, de facto standard of deploying everything. All right. Why API first design? So here is a definition of what API is. And I emphasize two words. So API stands for Application Programming Interface, which is a set of rules and protocols for building and interacting with systems. So if you think about it, this is really your language that you want to talk. Using this language, you want to talk to developers, and on the other hand, to your infrastructure. So what kind of API can we adopt? There already exists an excellent API with resources in Kubernetes. So we can adopt Kubernetes API. I'm going to show you how to express infrastructure or other platform elements. All right. Why it matters, as I mentioned earlier, it makes things simpler, standardizes, automates. And for us, for SRE, it's very important that if you build a platform, Kubernetes already is scalable. So getting with Kubernetes all the things that typically come with it. Again, here emphasizing that this is a product. So if you approach building a platform the same way as building a product, which is iterating, making small changes, you're going to be successful. All right, let's hop to the demo. So hopefully the demo gods are with us today, because it's going to be pretty involving demo. So what I want to show you in the demo is how those principles apply in practice. And this is one way of how you could build a platform. You're going to use a lot of tools, and I'm going to go through this quite fast because of the time here. But everything is available online, or you can chat with me later if you want to get a source code to any of this. Okay, so I am a developer. Let me swap hats. So you can see at the bottom here, or you cannot, because you don't see the bottom part. But anyway, so we are now on a developer view. So I develop an app, right? This is a naive app. This is my world. I'm a developer. I'm putting developer hat on. I care about the app. I maybe have a Docker file. Maybe platform team helped me write it, but that's about it. I don't know much else. I know I need the infrastructure for it. I know things need to happen. As a platform engineer, on the other hand, or SRE, I created something for my developers so that they can take this application and all required infrastructure and deploy it in a very simple way. So let me actually maximize it so you can see. All right. So how do we do this? First principle, you remember, we use some form of UI to expose to developers what they can do. And this is UI is called port. I hope it's big enough. Let me maybe zoom a little bit. So port is like Backstage. Anyone knows Backstage or use Backstage here? All right. No. So it's really just a UI that sits between you as a developer in this case and infrastructure or other elements that you can create using it. So the goal here is we as developers want to create my app, associated infrastructure, in this case in Azure, and do this really easily. Okay, so let me show you first Azure. You can see here we have a bunch of resource groups, one that really wants to be deleted, but otherwise there's nothing crazy here, right? Just a bunch of resources. So let's start. I'm going to create, and it just gives me a very simple options. It gives me name of connection string I want to use, which is a variable, an image, and a port. So as a developer, I click execute. What happens behind the scenes now, we want to make sure that we have a trace from port, or in this case from port needs to do something so that our app and infrastructure will be created. So what it does, behind the scenes, it creates a PR. So here you see a repository. The PR is right, almost done. It's an automated PR, right? So we have a PR, a bunch of stuff here. What is in this PR? I talked about API. Try to zoom it in. So we have a very simple Kubernetes manifest. It's not a native Kubernetes object. You Notice that it's called app claim. There's no such Kubernetes subset. This is obviously a CRD, custom resource definition. And it simply defines my app. So at the bottom, you can see some of the fields I was able to fill. There was no namespace because I wanted to hard code it. But otherwise, this is a file that is being now submitted to a Git repository. Let's do it. So we're going to go back. I'm going to pretend I reviewed it. And let's merge. When we merge, that's it, right? We merge a wish from developer. They said, I want this app and the associated infrastructure to be deployed. Now, as a platform engineer, I can use software like Argo CD. Who uses Argo CD? All right. So Argo CD is a project that enables you to synchronize a desired state from a Git repository in whatever Kubernetes cluster you want. So you can see that this is a Bootstrap app, but if I refresh it, we should start seeing a bunch of stuff happening, and we do. So on the right-hand side, all those things are Kubernetes resources. They just came from this small YAML file that our developer gave us. So we have things like resource group. We have here various things called objects. We have container and account. And those actually at the bottom, they represent an actual cloud infrastructure. So if we swap here, if demo gods are with us, we should see a new resource group called platform demo. We have platform demo. And this platform demo, if I can click correctly, I can do it. Let's only say, not sure why. Yeah, it's just weird that it doesn't click on exactly the. Okay, I wasn't expecting that to fail in the demo, that I cannot click stuff, but okay, I think we did it. All right, so you can see that here we have an actual storage account. Who uses Azure and knows what the storage account is? So who knows what a S3 bucket is? Everybody, okay. So storage account is an S3 bucket in Azure, right? I just used Azure for the demo. I like Azure a little bit more, but it can be done with any cloud. So we have created those things, right? And you can see as a developer, I went away, grabbed the coffee, and I want to know that my stuff is online. So how do I know it? Obviously via Slack, right? So now we have Slack message that tells me everything has been deployed. So I have something at localhost that says Azure Storage Blob Reader. This is my app I'm working on. This is going to make thousands of dollars. It's going to be great. So the app is running. My infrastructure is running just from this small YAML. And I have other things. I'm going to click probably through them. I have also observability. And I can say I have dedicated Grafana dashboard. I have Prometheus running behind. Everything has been created for me. I didn't need to specify. I didn't need to worry about it. And also here, I have my own vCluster. Why do I have vCluster? In this case, we are using vCluster to provide a sandbox for our developers. Typically, what happens with those types of requests, you give something to developers and they come back and want 10 more things, which is normal. So in order to provide them something that is useful, but they can experiment it in a sandbox, I'm providing here a virtual cluster. So I can go back and connect to it. I'm not going to show this to you because we don't have much time. I have later something else also with vCluster. All right. So this happened, and we can see this connected but no documents. So as a developer, I want to test it. All right. So I'm going here. This is my apps deployment folder. And inside of it, remember, we are using Kubernetes API all the way. So I have a special Kubernetes file prepared, another CRD that I can apply. KAF is just my alias for Kubernetes apply. And when I hit apply, it created another Kubernetes file. I will show you this file in a second, but if everything is correct, we should see go. So it changed, right? It applied another, in this case, what it did, it actually pushed a file to our storage account, right? Equivalent of a S3 bucket. We support icons. This is going to sell. This is going to be great. So our app is ready here, and we can experiment as a developer. I can take the content of this file. Let me show it to you. And I can change it I can create a new one and kind of test it. So this is how I could support the testing idea here. Okay. So now I am done with it from a developer point of view, and I could delete it. But before I show you the deleting part, let's do something else. Let's imagine that this has been successful and another team wants to have the same environment, right? So they say, I really like it. I want the same ability to deploy stuff to cloud in this declarative way, but I want to reuse certain things from the host cluster. So what we can do as platform engineers, we're talking now about multi-tenancy. So this is something that happens very often. You support one team, this team becomes, they might become your champions. There's somebody there that really likes what you're doing, and other teams follow, right? And then we suddenly are ending up from supporting one team into having a multi-tenancy scenario. So how can we do multi-tenancy in this already complex environment? That's where vCluster comes in. So I'm not going to show you for now vCluster setup, and we're going to show you a simple file. So how this works behind the scenes, there's a secret that allows me to communicate with Azure infrastructure. And this secret is specified in this Azure creds secret. When I would like to add another team 2, team 3, and so on, I would like to make sure that they can take some stuff from my host cluster and they can have some of their own stuff. This is a very common problem for Kubernetes or generally platform engineering, where if you have an ask, there is always like a balance. You want to provide some isolation in terms of multi-tenancy, but you also want to reuse certain components that you have. So this happens to be a vCluster YAML configuration file. So what we are going to do, we are going to deploy this virtual cluster, and this virtual cluster has its own tools. I know it might be a little bit confusing if you have never used virtual cluster, but what it does, it takes Kubernetes and all its components and puts it in a pod. And inside of your Kubernetes cluster, there runs another virtual cluster. All kinds of benefits to it, because you can obviously isolate. In this case of multi-tenancy, you can run tests or whatever you want to do. But let's just run it. So I have a Just. If you don't know Just, it's a super cool program. It's make, but specifically for running commands. And here I have vCluster setup. What this recipe does, it's going to essentially take the config file you've seen earlier, create a virtual cluster for team 2 that encapsulates some of the tools that we have here on the host cluster running here at the bottom, which is, by the way, my kind cluster running locally. Take some of those tools, but also take something from host cluster and create a very isolated virtual Kubernetes cluster just for this team. You can see at the top here, rather, there's a bunch of commands. We are installing Crossplane. I'm going to talk about the tools a little bit later, what we've used. And we are providing this reusable virtual Kubernetes cluster for the second team that is also excited about our infrastructure and platform and wants to use it. So we give it a moment to deploy. Okay, that worked. Pretty happy so far. And one more command. So remember, the goal was that the team has the same kind of ability to create infrastructure, right? So we have another command here. vCluster create claim. So what this does in turn, this is going to provision another Azure infrastructure just for this team. This will take a while, but if you're lucky, we can see in Azure here, if the clicking works, that there will be a new resource group. Yeah, there we go. Platform -2 demo. And this resource group contains another storage account. So a lot of moving parts. And again, as I mentioned, this is a very practically oriented solution. So you can just apply some of it. But I want to bring it all home and guide you really quickly through what we did and why. So the delete part I'm not going to show you, but it's equally easy. You go to port, you go here, you click delete action, and the whole infrastructure is removed. Everything, including infrastructure, services, Kubernetes components, and so on. So let's swap back to presentation real quick. And I'm going to show you what we've done. So what are the tools that we've used behind the scenes? First of all, we used Kubernetes, but we didn't use Kubernetes as a container orchestrator. We used it as a control plane. Kubernetes has this native ability to run control loops, and we can take advantage of the control loops it does and control literally anything. We can control internal Kubernetes resources, pods, deployments, replica set, but we can also, using CRDs and extensibility model, control external resources. In our case, we are controlling actual cloud infrastructure. We used vCluster, again, virtual cluster. We can have, if you work with a lot of teams, so if you have to create a lot of host clusters at work, this will be something interesting, right? Because now instead of isolating your teams with actual clusters, host clusters in AWS, GKE, wherever you're doing it, you can now create virtual clusters inside of them. And we use them in kind of twofold. So one way we use virtual cluster is we gave a team of developers virtual clusters so they can play around with it. And at the end, we use virtual clusters to isolate another team, which has all kinds of benefits. All right, we use also Crossplane. Crossplane is like Terraform, but Kubernetes specific. So what is better about it than Terraform is that it uses, again, control loops, and it has built-in drift detection. So Kubernetes tries to reconcile your cloud resources. We use port. We use GitHub as an interface, really. So PRs, or think of them like messages in message queue. We use it as an interface to get things done. Argo CD for GitOps and kind locally here. So for those of you who like to learn visually, this is what we did. Same idea. Developer logged in to port, clicked the button, stuff went to Git repository. This Git repository was observed by Argo CD. Argo CD grabbed the file, applied it to Kubernetes, and in Kubernetes we have a bunch of tech like Crossplane, like vCluster, and other things that actually made the magic happen. And Kubernetes reconciled all this for us, and it resulted in a bunch of resources inside of Kubernetes and outside of Kubernetes. All right, I'm almost done. Just see this one more slide. Yeah, so we reduced friction for developers. There was almost no waiting time. We just approved the PR, right? That was super easy. We could also ditch this completely and trust developers. Eliminated waiting times, used this interface, and we didn't mention AI even once, which is cool. All right, so thank you. And if you want to get in touch with me, you can snap this QR code. Again, reminder, go to Cloud Rumble if you want to see all the cool stuff and other talks. Otherwise,
questions?
I can see from the stickers on your laptop that you mentioned some of the technologies I've been looking into it, one of them being CDK ADAS. As I understand, I haven't really played a lot with it, but as I understand, the major alternative for Terraform currently are Crossplane and Pulumi. Pulumi being more code-centric and Crossplane being more cloud-native and YAML-centric. What's your experience so far with CDK8s throughout, I think, probably Crossplane YAML manifest?
So I don't use CDK8s because I've used it in the past, because what you said was like Crossplane a few years back, which only had YAML. But now since 0.19, I believe, Crossplane has also support for programming languages. So you can create compositions. This is Crossplane specific. So composition is actually, I didn't show you this because I didn't have time, but it's a gigantic YAML file or gigantic Python code or whatever you want. So Crossplane supports now something called functions, composition functions. And you can use, I believe, Go, obviously, Python, and I think we added Rust lately or something. So it works very similarly. Whereas CDK is okay. It's a little bit more focused on AWS as it comes to primitives. But with Crossplane and composition functions now, there's no reason to use CDKs. Good question.
More questions? All right. Thank you.
Cool. Thank you, everyone. Unplug. I didn't trip off. Keep your didn't trip on the cable. That was good.